This video is on integrating functions of the form ax plus b. Once again, there's a few rules there for you to have a look at and write and note down and to use when you are completing questions. And we just have 8 examples to go through, showing all different ways you can see these types of questions. So first one, we want the integral of 2x plus 3 all to the power of 4 dx. So if you look here, we use that second rule there. Now we've got a, b and n, so we just need to know that the 2 is the a, the 3 is the b, and the 4 is the n, and then we can just sub those values into the equation, which will give us 1 on 2 multiplied by 1 on 4 plus 1, and then we have the bracket stays the same, and then we add 1 to the power as well, and then plus c. And if we simplify that, we'll have 1 over 2 times 1 over 5, which will give us 1 over 10 of 2x plus 3 to the power of 5 plus c. B, we've got the integral of 1 over the square root of 1 minus 3x dx. The first thing I'm going to do with this one is rewrite it, which will give us the integral of 1 minus 3x in bracket to the power of negative a half, because that gets rid of the fraction and the square root. And then do the integral of this, which would be 1 over a, which is the negative 3, because the a is the value that's in front of the x. We'll have 1 over negative 3 multiplied by 1 over negative a half plus 1, which will be 1 over a half. Bracket stays the same. Plus 1 to the power, so negative a half plus 1 is just a half, and then plus c. And then simplify this. We'll end up with negative a third times a half is 2 on 3, so negative 2 on 3, 1 minus 3x to the power of a half plus c. And then if you wanted, you could put the bracket back into a square root if you wished. Part C, we've got the integral of 2e to the power of 2x minus e to the power of negative 3x dx. So the a in this one is the 2. There is no b because we've got nothing added in the power. Therefore this one will be that 2 stays out the front, and then we'll have that multiplied by 1 on a, which will be a half. E to the 2x stays the same. Then we'll have minus 1 on negative 3 e to the negative 3x, and then plus c. And then if we simplify this, 2 times a half is just 1. We'll have e to the power of 2x plus, because we've got minus negative 1 over negative 3, plus 1/3 e to the negative 3x plus c. D, the integral of 2 sine 3x plus cos of 4x plus pi dx equals of 2 sine 3x first. So in this one, this part, 3 would be the a, there is no b. So we'll have the 2 times. Now, the integral of sine is negative cos, so we'll have negative 1 over 3 cos 3x. Now, in this next part here, the 4 will be the a, the pi will be the b. And this will give us plus, integral of cos is just sine, which means it stays positive. And then we'll have 1 over a, so 1 over 4, cos changes to a sine, and then the bracket always just stays the same. Simplify this, we'll get negative 2/3 cos 3x plus a quarter sine 4x plus pi plus c. Part E, the integral of 1 on 5x minus 3. And this is where we have to bring logs into play. So the a would be the 5, and this would give us 1 on 5, because it's the 1 on a, and then ln, then the whole denominator in the bracket, and plus c. F, 4, the integral of 4 over 1 minus 2x dx. This one, remember, we can, if we wanted to, write it like this, as the 4 on the top is irrelevant and is just a number that we multiply at the end. And then we can do our integral, so it'll be 4 times 1 on a, which is the negative 2, because that's in front of the x. It's 1 on, so it'll be an ln, the denominator into the bracket, and then plus c. Then we can simplify this to 4 over negative 2, which will be negative 2 ln 1 minus 2x plus c. G, the integral of 2 minus sine x all squared dx. Easiest thing with this one first is to expand the brackets, which will give us 4 minus 4 sine x plus sine squared x dx, and then we can do our integral. Now sine squared x, we don't have a way of doing the integral of that, which means we need to use one of our identities to help do the integral of this. Now with the identity for this one, it is for the sine squared x, it is a bit complicated. It does just use the ones that we know already. I'm just going to write it down here. So one of the ones we know already is that cos 2 theta equals 1 minus 2 sine squared theta. So to get rid of a squared in there with our sine and cos, this is the one we need to use, but we need to make this sine squared theta equals. And so when we rearrange that, what it will actually give us is that sine squared theta equals a half minus a half cos 2 theta. And so that's what we're going to replace sine squared theta with here. Means we'll get the integral of 4 minus 4 sine x plus a half minus a half cos 2x dx. And now we're going to do the integral of this, which would be 4x. Integral of minus 4 sine x is negative cos x, which means it would be a plus 4 cos x plus a half will become plus a half x. Now then with this part we'll have minus. The half stays, multiply it by 1 over a, which would be 2, because it's 2x after the cos. Integral of cos is just sine, so we'll have sine 2x plus c, and then we can simplify this. In the simplify we've got 4x plus a half x, which will give us 4.5, so 9 on 2x, then plus 4 cos x minus a half times a half, which is a quarter, sine 2x plus c. And that is the end of this video.